talked about what a random forest is, how it builds on bagging and makes it slightly better. Now let's talk about how to actually do this in R. So I'm going to use a heart disease example here that I used for the classification trees. And recall that I'm predicting whether a patient has heart disease from 13 predictors. And so the first step is going to be to randomly divide the data in half. In this case, I'm going to have 149 training observations and 148 testing. And then I'm going to create a model specification. And so I'm going to use the rand forest here as my as what I'm specifying instead of the decision tree we were using before. The mode is classification, so I still set my mode. And then I set this M try, so that's going to be the M. And so if we're doing bagging, what do you think we would set this to if I was doing just normal bagging? So if I'm doing bagging, I'm going to set M try to be the same as P. And so basically the same as the number of predictors, in this case 13. Now what if we were doing random forest? What would I put there? So I would put, I'm going to try 3 here. You would want to pick something that's close to the square root. So you would take the square root of 13 and approximately see what that's equal to. It's something between 3 and 4. And then I'm going to set the engine to be Ranger. So this is how I'm creating the random forest specification. The default for the rand forest function is the floor of the square root of the number of predictors. And so in this case, the default is going to be 3 as well. And then you need to fit the model. So here's the model that I'm going to fit. I've got my predictors along with my outcome and my data set. And then you can examine how it looks in the test data. So I can pull out the testing data. I can predict how it does in the new data. And I can look at this confusion matrix that basically shows me how well I do compared to, my prediction does compared to the truth. And so I can see here kind of how well we're able to estimate compared to the truth. Okay, so what I want you to do now is go back to that application exercise where you answered that question about M, and I want you to pull in the application exercise from last class where you fit a model using a decision tree and then you plotted it. And I want you to fit that same model, but now I want you to do a random forest instead of a decision tree. So think about the M that you should choose for this random forest, use that rand_forest function, and go ahead and fit that model and see how it performs.